Hello everybody and welcome back to the series. Today I'm going to be doing a recap of everything you've learned. Do note this is a revision resource, and if you want to learn the things, have a look at my full videos. I highly recommend watching them. To revise this subject, you should use this video as well as the cheat sheet document I'll be putting in the description. That document I'm talking about is made by EDEXCEL, and it's what they use to make the exams. So everything on there, everything in your exams will be on there. So if you learn that whole document, you'll know everything for the exams. Also, I'm going to be following the format of the document in this video, so you can follow along if you so as wish to. Also, I'm going to be skipping the very basics of Python. If you want to do that, look at my basics video. So first of all, here let's talk about data types. There are a couple of different data types in Python. So the ones you want to talk about are integers, which is expressed as an int, real or just float, which is just float, booleans, which is bool, and then strings, which is str. So int is just a number with no decimals, float is a number with decimals, bool is true or false, and string is like text. And string is defined by putting text in double quotes. Do note that Boolean values need a capital letter as their first one, which is different to quite a lot of programming languages, so keep that in mind. There's also lists, which is another data type. You define that with square brackets and you separate items with commas. So there are two types of lists. There's an array where all of the items are the same type, like this, or there is a record, as they call it in the specification, where different items, different types, but they're both defined in the same way. They're both just lists. Do you know, you might be asked about characters. There isn't any strict difference between characters and strings within Python. So a character is basically just a string with one letter in it, which kind of makes sense. Or not one letter, one character. So constants are variables that cannot change. I'm assuming you already know what variables are. And the format you type them in is called screaming snake case. So if I wanted a constant for file size, I would say file underscore size is equal to whatever. And so it's full caps and spaces are underscores. And so constants should never change. Obviously, in Python, there isn't any strict definition of them, so in theory they can change, but you should never change the value of a constant. You can convert between different types using something like that, or the one you're going to use the most is int, and so then you put whatever you want in here, so like that. And if I go over here into my little live thing, if I convert 66 as a string into an integer, I just get the number 66. And so obviously I can do vice versa. I can just say that and I get the string 66. Oh, this is a good point. If you double quotes and single quotes are equivalent in Python. So if I said single quote that would be the same, but do note they don't link up with each other, obviously. Let's move on. Operators. Operators are a way of comparing or mixing things. So there are arithmetic operators, which are maths things. So there's slash, which is division. There's asterisk, which is this little star, which is multiplication. There's two stars, which is like to the power of exponentation. Exponentation. So that's like, if it was 2 to the power of 4, it would be 2 star 4. And then there is just plus. Do note about plus, you can add numbers, but you can also add strings together. I'll get to that in a second. And then there's minus, which is minus. And there's double slash, which is into the division. So what this does is when you divide two numbers, division often gives you lots of decimals. So this will just round it down. It's sometimes called floor division. Integer or floor division, double slash, just rounds down the result. Then there is percent as well, which is modulus or modulo. This just gives you the remainder of a division. And so the most often occasion you'll see this is for something like checking if something's a even number or not. So you'll have x modulus 2, and if the remainder is 0, then it's even, and if it's not, it isn't, for instance. And so those are the arithmetic operators. Do note these are all in the document. And then there are relational operators. So arithmetic operators take in numbers and give you numbers. Relational operators take in any type and give you a Boolean value, which, as I said before, is a true or false value. So there's double equals, which is checking if things are equal to each other, and it's double equals instead of single equals because this is for defining something to a value. So if we have this very similar example, this is saying A is equal to 6, and this is asking if A is equal to 6. And it will return true if A is 6, false if it isn't. The exclamation mark equals, which is not equal to. There's obviously all of your relational operators should know this from maths. If you want to do greater than or equal to or less than or equal to, you do that sign and then an equal sign. So then there are what are called logical or Boolean operators. So these take in Booleans and give you back Booleans. So you might have seen this from the paper one stuff. There's and, or, and not, which you need to know about. And these are fairly obvious. If I have A is true and B is true, then it will return true. But if only one or none of them are true, then it's false. Or if any number of them are true, then it's going to give you true and not. It just takes one thing rather than two, and it just inverts it. So in theory, you can use it in place of a not equal to relational operator. Once again, these are all in the document. So now let's talk about if statements. Pretty simple. If, and then here you will have either a relational operator or a logical operator, anything that returns a Boolean, or even just a variable that's got a Boolean in it, or just like a Boolean. So if needs to know it should be either true or false, right? So you say if, and then the condition like A is equal to 6, for instance, and then a colon, and then do a new line. When you do a new line, it should indent for you automatically. If it doesn't, or you need to indent yourself, simply hit the tab key on your keyboard, and it should jump you forward 4 spaces. Indentations are really important because it shows what's in each other. So if I have something like this kind of stacked thing, you see I get more and more indented, and so then you just have your code here, and this code will only be run if the if statement is gotten to, because this condition is true. And so you've also got this else block if the condition is false. So this is works same indentation, code run, colon. So yes, this is just a catch-all, whatever. But then you can also have something in between here called an elif, which is a combination of an else and an if. So this would be the same as saying, yes, it's equivalent to saying else colon if, right? But basically, this is just like a second condition, and the difference between if this was just an if here, is that if it was just an if, both of these would get run. Because an elif, this would only get checked if this was false. That's why it's else if. Right, so now we've got onto loops. Right, that was selection. Now we're onto loops and repetition. So we've got the while condition, which is very similar to an if, where you have while and then anything that returns a boolean. So you can even have while true, which is just will loop forever. And so it keeps running whatever code is here until the condition is false. So while whatever's here is true, run the code, as you can see. So, oh, crashed it. Yeah, do be careful with that with while statements, while true statements, they may crash because it's an infinite loop. Yeah, so you can put any condition here, so you can just do the same sort of thing. So while a equals 6, right? And it will just go looping indefinitely. So this is different to the next loop I'm about to talk about, the for loop, because while does not necessarily have a defined end. It could go on for an infinite amount of time. As a for loop here is a kind of finite loop. It's called iteration. So this one's slightly more complicated. So what you're going to need to remember is for something, I usually use C, count, that sort of thing, in, range, and then how many times you want to do that. So this is a pretty simple one. All this does here is it runs the code here, but each time it increases the value of I. So I starts off at 0 and then goes up to 7 here because it's 8 exclusive, right? So it goes up to 8. And so that's really useful if you just want to repeat codes over and over. And as you can see, I can actually extract this I, and it's actually got the value. So this runs 8 times, and I can see which item of the loop I'm in, basically. And so this is a bit more customizable as well. So I can start from a certain value, so it could be a positive value, but I've just gone for -5. As you can see, it starts from -5 and goes up to 8. And I can also change the step by adding an extra thing. And that's how many times it jumps each loop round. So we start at -5, we're ending up at 8, and we jump 2 each time. Start, end, step. And obviously if you want to put a step in but you don't want to put a start in, just 0 is the default start, so if you do that it will just work normally. And there's another type of for loop. Let's say I have a list here. And I want to loop through every item in this list. I would say for I or item or anything, doesn't matter, this is just a temporary variable effectively, in, and instead of saying range or something, I would say the name of the list, colon, and then I can do whatever I like with this. This I is that item, you see? This I is each item of the list. So here we go, we print out all of the items of the list. So that's very useful, remember that. For I in, then list, or you can do it with range, just to do it with numbers. So now let's get on to subprograms, typically called functions or procedures. So you say def to start it. This is a weird keyword. Most programming languages use function or or whatever, but they use def in Python. So you don't need to think about the other ones. Def, and then you say the name for it. Let's just say, and then you put brackets here, and then a colon, and so then you can print something or whatever. And so if you run the code, you'll see nothing happens, and that's because this has to be called. So what you can say is multiply that. So basically, this is a little bit of stored code that you can run at any time you like. This is called a procedure, and I'll explain why that is in a second. So as you can see, these brackets are empty. Why are they here? That's because you can pass arguments in. So if I wanted to do that, I could say that, and it actually does what it says. And I pass in two numbers like that, and you see it's multiplied them to 20. So what I've got here is I've got two parameters of what these are called. So what these are is these are kind of a little space where a variable will actually be. These don't have a definition yet when I'm making this, but you see I print out these two values times together. So here, what I'm doing when I'm calling this is I'm setting the value of a to 4 for this specific call, and the value 5 to b. And so these are called arguments, and these are called parameters. You see? Different but the same. So another thing you can do, so these are procedures. So another thing you can do is I can do this, return. So now what's happening is I've made a function. This is no longer a procedure because it's a function because it returns a value. So what I can say now is something like that. So what happens is this code is run through this function, and it returns something. So it gives something back to the code, and what it does here is it returns this value, which is 20 in this case, and that lets you put it into a variable here at test, and then we're just printing it out. And that is very useful for all sorts of things. And so you may notice this is a lot like something else you used, which is the input thing. You have to set a value to it because it's returning a value that happens to have been got from the user. And so I'm assuming you already know what print and input do. First things you learn. If you don't, look at my basics video. So now let's talk about files quickly. Went over that recently. So open, and then file name. I'll quickly prepare some files for you. So what you can see I've got here is I've got this text file, test.txt, which is in the same file as this Python file. So what I can simply do is say open, and then the file name is test.txt. Remember, you need to put the ending on it. Comma, and then for now just put R. So what this will do is this will open this file here in read mode, which lets you read the contents of it. So there are a couple things you can do with this. First of all, you can simply set this to set all of the stuff that's inside of this file to a list. And so, so what you should do with this is you should set this file to like a variable like this. So remember, this open actually returns a file, which is a bit weird to think about. So do you know, when you read from files, the stuff you read kind of gets eaten. I don't know how to express it better than that. But basically, once I've read something in, the version of the file I've got no longer has that in. So if I say test file dot read lines, So if I then try to show you what's in here, see I've got this list of the contents of this file. And so, yeah, a thing to note with this is that while the ending often won't show up here, you need to put the ending here. And so this is a text file, so it's got .txt. This is a Python file, so it's got the .py extension, etc. And you can work that out from this. So as you'll see here, the list returned has these \n in, which, if you don't already know, are new line characters. So just the same as clicking enter on your keyboard or something, but you don't have to actually put a new line there. So even though this is split, each line split up into a list, it's got the new lines in it, which it might be a bit weird for printing. You'll have to work around that. So what I'm saying about this eating thing, if I say read line, right, that just reads the next line along, so it's just said hello. But then if I do it again, let's say, then it goes on to the next one. And so you see, if I then print, if I then do that, as you can see, what's happened here is I've kind of eaten up these lines. I don't know how to express it, but these lines have kind of been used up. And see, when I try to read all the lines, there's none left. So it just returns me an empty list. So it's important to remember, it's not like, you don't get a list back. If you want to get a list back, you set a list to read lines, right? What you get back is a file, and you read through that file. And so if you want to iterate through the file, you don't have to set it to a list. You can simply just say for line in test file, and this will iterate through it as if it was a list. Once again, kind of eating them. This doesn't have to say line, it can be anything. Yeah, that can be anything. So an important thing to remember, always close your files. So you want to say test file, or whatever your file's called, .close at the end of your file. This is less important for reading, but still important. So now let's get on to writing and appending modes. So I'll just leave this here for now. So if I change this R to a W, I'm now in write mode. So what I can do is I can start writing things to here. So the format follows pretty similar to the reading, except backwards. So let's say I wanted to replace everything in here with my own sort of thing. I'll close this so I can just reopen it later. So I'll say test file dot write lines. Write lines, bracket, and then if I say write lines here, I need to put in a list of strings. So this is kind of the same format as what you read in is what you write in as well. So you do need to remember these \ns for the new line after each list item if you want a new line there, which is weird. Don't know why it's like that. So if I say something like that, write something different. So do you remember it said hello world before? Now I run it, and you can see this is actually changed to this text. So if I just want to write one line, I can just say write, and then not a list, just a string. And then here, just change it there. So remember, you close this file every time. And so now I can also put it on append mode, where instead of replacing everything, so you saw it all got replaced, appending just sticks a bit on the end. So this should say yo-yo. And if I reopen it again, it's just adding a bit on. And so yeah, do note, while it's read line and read lines, For write, it's just write or write lines. That is weird. Why do they do that? No idea. So yeah, that's files. Important bit. So let's have a quick chat about chur and ord. So these, they may ask you about. What this does is this is to do with ASCII and Unicode and that sort of thing. So let's go over here into, oh, I've got two of these open. Let's go over here into our live environment, and if I say ord and then the letter A, I get this number back. So this number is the decimal value of where A is, lowercase a that is, in the ASCII table. And so, oh, whoops, you should know already about ASCII from the other bit. It's text encoding thing. So this just gives you back the numerical value, and then chur does the opposite. You put in the numerical value, and it gives you back the character that goes with it, which is quite useful. They'll ask about that. Just remember, ord, you put in a string, you get out the number where it is in the table. Char, you put in a number and you get back that letter. So a quick one that's useful. There's round. Oh, whoops. There's round here. So I just put in like whatever number. So if I had 6 dot da, 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 right, big number, want to round that to a value, I say then comma in here, and then how many decimal places. So if I wanted to do this to 2 decimal places, I would just put a 2 here, and so you see that's rounded it to 2. Remember, it will round up if it's 5 or above. You should know that from maths. And so yeah, you can change however much decimal places it does, including 0. And as you can see, this is a bit weird. It says 7.0. This is because it's returning you back a float value rather than an integer, even though it has no decimal places. Do you know also this is decimal places, not significant figures? This is decimal places. So now let's talk about lists really quickly. So if I have a list, let's say, let's just give us an empty list for a bit. If I say dot append, this will simply attach a new like item onto the list. So as you can see, I started off with an empty list, chucked an A on the end, boom, list with an A in it. You can use well, let's talk about quickly about indexing lists quickly. Let's have some sort of list here, just a one-dimensional one for now. So if I say my list square brackets 1, this will print B. Why? So what's happening here is this is indexing. So starting from 0, all of these ones are numbered. So this is 0, this is 1, this is 2. So I can get all of these out by typing in their respective number values. You can delete a certain item of the list using the indexing thing again. And you see I start off with that, now I'm at this. That's useful. And you can also insert into a list by saying my list insert, and then you say the item, no sorry, you say the index and the item. So if I wanted to put this in at the first area. You do that, and so let's say that. As you can see, it's put an X at the beginning, but this can be anywhere. This can be next one, so on. Right. So that's quite useful as well. Another thing you can do is my list. Sorry, not dots. Actually, you have to say len my list. Actually, let's get the list back quickly. So len my list. This will give me back the length of the list. Do note, if you're going to use this for like looping through the list or something, this starts counting from 1, right? Because it's the amount of items in the list. 1, 2, 3. But this is actually 0, 1, 2. So you're going to have to take one away if you need to. This also works for strings as well. The length function. So let's just say this is my string. And you see, sorry, I spelled that wrong. So as you can see, this gives me 5 because there are 5 letters in hello. And so there are quite a few of these string things you might want to know. If you want to find a specific item within a string, I will say my string dot find, and then whatever I want to find, so I want to find E, and so this will return me back the index of it. So remember the indexing before, it returns you back the number position where it's at. So you can see 0, 1, 2, 3, first one, or no, second one, the index 1 is where E is. So also to note, if it can't find it with find, it will return -1. But if you use myString.index instead for this, it will raise an exception, which is this, as an error, right? If it can't find it. So remember the difference: find -1, index, crash, program ends. So there are a couple of things for verifying strings and that sort of thing. So if you want to verify if something has a specific format to prevent errors and that sort of thing, there is kind of a better way of doing it in Python, but the way you should do it for this example specifically is like this. So if I want to check if it's like alphabet, I say .isAlpha, right? And so as you can see, this is all alphabet characters, true. But if this was numbers, as you can see, it would say false. So if I said alnum instead of alpha, this will check if it's alphanumeric, which just means numbers or letters. So here, true. Let's give it some letters, true, and then mix of both, true. And then we can also do is digit, and so this checks if it's only numbers, the equivalent of is alpha for numbers. So you can see that's false because I've got mixed things, but then if I just put numbers in, that's true. So those are useful for double checking that the types a user's putting in are correct without crashing the whole program. So there's a couple other things similar to find for editing strings. So I can do string.replace. So let's say this was the word good here, not good. I can replace a letter with the letters changed. So if I wanted to change all the O's to E's, I'll do that, and it would work. Do note with this doesn't edit the original string. This just returns an edited value of it. So if I wanted to change what the original string was equal to, I would have to do that. So there is also string.split, which, let's say I've got this big sentence with many words separated by spaces. What I can do is string.split, and then I can say at a character, the default character is in fact space. Whoops. And so remember this just returns as well. So let's do that. And so you can see all the spaces have been replaced with a split here. So this can be with any character as well. So I can just do it with the letter E. And as you can see, it's split it up here. And remember, it gets rid of that letter. So then there's also .strip as well. So let's say I had lots of spaces on either side of this string. Let's just leave this empty for now. What this will do is will simply take all of those characters from the front and back, and this once again works with any character. So if I put in dot instead, see they're all gone as well. And so yeah, that's quite useful for kind of fixing strings. So now if I have a string and I want to kind of like mess around with the case and stuff, I can do that. So I can say my string dot upper, and once again this returns rather than edits the original. This will return the string. Ooh. Sorry, did that completely wrong. This will return the string in full caps. If I say lower, as you can see, this H was capital no longer. And also I can just check if it's all lowercase. So this specific string will actually fail all tests because it's got part of each. So if I do is lower now, because it's all lowercase and it says true, and that would go the same for uppercase. So there are also format strings, but I think I'm going to leave that for my format string video because I feel like it won't be worth explaining it all condensed. So go watch that. Let's quickly talk about import libraries. So if you say import and then a module name, like random for instance, it will import that module. So what this is Python has a load of extra utility things that are kind of hidden away by default. And you have to import them. So you don't have to download anything or anything for these. There are ones that you can do that for, but it's just Python's got kind of extra hidden away ones to not confuse people. So let's talk about the random one first. So you can do random dot rand int and give it a range. Let's print this out. And it will give me a random number, which is quite useful. Yeah, that was just luck. So I can also just do random.random, funny name, and that will give me a float value, so decimals, between 0 and 1. And so that's literally all you need to know. Random.rand int with the range, or random.random just for some decimals. So there's also the math here, not maths, math, because Python's made by weird Americans. So you can say math dot seal, and then whatever float, and this returns a that number rounded up. As you can see, it's a 4. Typically, if I just did the round, it would round down, but I've done seal, so it will always round up no matter what. If I then math.floor, and let's just say this is a 7 here, it will always round down no matter what. I can also do math.square root, which is square root, so let's just do the square root of 16, and it's given us 4. As you can see, 4.0, this is once again because it's returning a float value, so that's just what float values look like. And also, quite an important one, if they ever ask you, math.pi, that's just pi. So that's the math library. So now let's talk about sleep. So if I say, time. So if I say time.sleep, and then put in however many seconds I want, it will literally pause the program for however long I want. So as you can see, it waits 6 seconds, and then it prints out the second thing because this slows down the whole program. So once again, I think I'm going to leave the turtle stuff for the turtle video, just because I think I explain it better and it's quite a big thing. So yeah, that's about it for the Python. Remember, there was some content not covered in this video simply because it's quite big. First of all, the debugger was not mentioned at all. Watch my debugger video for that. Turtle, quite big, quite complicated, don't want to rush through it. Watch the turtle video. And also the very basics of Python were not covered either, so remember to watch my basics video. So yeah guys, thank you so much for watching. Thank you so much for watching this series, really. You're the reason why I'm making these videos. I just really appreciate everyone who's watching, even if it isn't very many people. Like, subscribe and stuff. Watch out, there's going to be at least one more video in the series. I'm going to be doing a walking, talking mock, I think they call them. Effectively, I'm going to be going through a mock and explaining my thought process, because lots of people have said to me, they just don't get the problem solving of it. Right, my friend said this about maths, actually. The problem solving bit is quite hard, so I just want to show exactly what I do when I get this big long document with a load of instructions and a Python file with some code in it. So watch out for that. It's going to be blind. I'm just going to go through it blind, and you're going to see how well I do. So yeah guys, goodbye.